This is Malawati Johannes. In today's lesson, I want us to discuss more about the mounting, sample mounting. We've got two types of sample mounting. We have got a cold mounting and a hot mounting. A hot mounting is a type of mounting wherein you are making an epoxy, within a chamber. Then you are putting the hardener under intense temperatures. Then by so doing, you're gonna harden the rock into what we call an epoxy. That is what you call the hot mounting. But we've got a type of a mounting which requires no intense temperatures, but everything is happening under moderate temperatures. That type of mounting is what we call the cold mounting. And then the cold mounting, it requires the resin and the hardener, and then you put them inside a cup, stir them, and then pour them into something like this, and then you put these things under an oven to remove some of the moisture, and then maybe leave that for about let's say 2 days or 24 hours. But sometimes 24 hours is not enough. You'll see the resin still sticking. It means it's not yet hardened well. So usually you can put that under maybe for 2 days, and then it will be fine. And then to make sure that we don't have what you call the bubbles, you after stirring, you put that into the oven. All right, so without any further waste of time, stay tuned. Please subscribe to our channel, like our channel, and comment for more content like this. So stay tuned. Let me take you through how we are basically making the cold mounting. And usually this kind of a mounting is for the scientists who preferably want to study what you call the Zircons and or the sulfides, and then basically in situ. Okay, so because when you are doing an in situ, you are focusing at a particular grain. All right, so unlike the bulk or the rock bulk composition, wherein you're just crushing the rock and give you powder. But now with the bulk composition, it will have an effect when you're going to be interpreting the results, because when you're doing a bulk composition, you are being too generic. But when you're doing in situ, you wanna focus at a particular geologic process for that particular grain. So stay tuned. Let me show you how. Okay guys, firstly, the procedure for making a cold mounting, it requires an epoxy kit, which is available from the electron microscopy sciences, usually in Fort Washington. But you can also find these from what you call Struers, which is in basically Denmark. But some of the laboratories, some of the advanced laboratories are having these epoxy kit. Now the epoxy kit, it consists of an epoxy resin. So within this you'll find an epoxy resin, and then this epoxy resin, it contains what you call the bisphenol, and then also we are having what we call a hardener. And then as you can see, this is the hardener, epoxy hardener, and it contains what you call the triethylene. I hope I reading it correctly. Yeah, you can see it contains this one. And then you are also having what you call 2 syringes. All right, two syringes. You're having this one and this one. And then when are we using this? We are using this when we are mixing this resin and the hardener. When we're mixing this resin and the hardener in what we call parts by volume. So usually you use what we call 15 parts of the epoxy resin. You draw it until it's somewhere here. It's 15 by parts of these resin, and then here you put 2. All right, and then that's when you are mixing. And then obviously after drawing these things, you're gonna pour them inside the paper cups. All right, and then you have what you call this is the paper cup. All right, and then this is the wood styra. That is what we're going to be using to stir this. All right, so now if you are using 15:2 by volume, after that you put them inside the paper cup and stir them for 2 minutes, and make sure you are precise. All right, so the epoxy kit, you're gonna find these hood stirrers, and then you're gonna also find these cups, these paper cups. I think they're about 10. And then you also have these mounts. You also have got these mounts, and then obviously you're gonna make it something like this, and whatever that you have made inside the mixture, you're gonna pour it inside. Okay, so what you also need, you need what you call double-sided sellotape. Usually this size, it's good as compared to this one, because this one is huge, it's thick. So if it's thick, this thing, it won't be able to fit nicely. But if it's this one, it will be able to fit nicely. So as I've explained, that this is the epoxy kit, and you also need what these gloves, so that you have, because the mixture, it will be too hot, so a bit hot, so that you avoid the unnecessary damage to your skin. And then you can also find this just to make sure that every leak you wipe it. All right, and then yeah, so let me quickly now show you how we are going to apply this epoxy resin and the hardener, and then also how are we going to pour it inside this, and then until it's taken to the oven, until it's left for about 24 hours or a day to harden. Okay, so stay tuned, let me take you through that. Yeah, so step number 2, we need the weighing equipment. You can use what we call the precisor with the model BJ6100D, and then as soon as make sure it is plugged, and then you can now switch it on. And then after switching it on, you put this cab right over there. But now, before you do anything, make sure you press T to cancel any previous information. Then what we're gonna do is we are using this precisor to mix the resin and the hardener, not by volume but by weight. All right, so we're gonna mix what we call 25:3 by parts. So we are now going to pour 25 by parts of this resin. Okay, check the scale, and we have to make sure that we are a bit precise. All right, so you pour this thing until it's written 25. Okay, precision and accuracy is what we are always hoping for in science. All right, so a bit. Okay, a bit. Ooh. Yeah, not bad. And then now you clear it again, and then now make sure that you put 3 grams of the hardener. All right, remember first time we put 25 grams of the resin now, and then you clear with T here, and then now you put 3 parts of this hardener. Okay, we are almost there. Whew. Oh, wow, that was great. All right, now everything is fine. You remember I told you about the leakage. Now I pour this, I mistakenly poured this on top of the weighing machine, so I would need that a paper to wipe everything so that it doesn't the mixture doesn't stuck here. All right, so that was step 2. And then what are we going to do now? Immediately after you have poured your resin or you've poured your resin and the hardener inside this cup, you need what we call the hood stirrer. All right, you need this. All right, you need this. And then what are you doing now? You are going to set a timer for at least 2 minutes, but you can do more than that. But make sure you don't stir this for less than 2 minutes. Now you're gonna stir this. Setting my timer now, and then please stay tuned. I'm gonna come back after 2 minutes. Now step 3, after stirring for about 2 minutes or more, now you can see we've got a lot of bubbles in the cup, and then we don't need these bubbles because they're going to tamper with the analytical machines like SIMS and the ablation machine, or any other analytical machine we can use for the in-situ analysis. Now these bubbles must be removed. How can we remove this? Any oven you put this cup for at least 3 minutes, and then so that we remove these bubbles. So I'm gonna put this in an oven at the temperature of at least 40 degrees or 45, 40 or 45 for 3 minutes, and then I'm gonna leave this in an oven for 3 minutes, and then I'm coming back shortly. Now after you put the cup inside the oven for about 3 minutes, you would notice that the bubbles are right on top. And then what you need to do, you need to push these bubbles aside. You push them aside like this until you have few of the bubbles, because if you put this mixture with these bubbles as they are, they still gonna have a bit of an effect when you're going to be analyzing your mounts. So just make sure that you do this until we've got a few of the bubbles left. Okay, but you can now see that the oven helped us to separate these or to make sure that we have got the bubbles right on top. Then now we're gonna remove the bubbles like that. Okay, Now notice that we have few bubbles, but if you can keep on separating the bubbles or crushing those bubbles, you can reach a point wherein we've got few less bubbles. All right, now what do we need? We need the double-sided sellotape. All right, we need double-sided sellotape and a scissor or a razor blade. Now after using the scissor and the razor blade, you're gonna have the double-sided sellotape of this size. Now remove this, and then after removing that, you need what we call the lid. This is the lid, and then this is what we call the fixed form cylinder. This is what you call the fixed form cylinder. All right. Okay, now you put this fixed form, like this. All right, and then make sure now that you place your double-sided sellotape at the center. All right, why at the center? So that when you assemble them together, it's gonna fit nicely. All right, so this is your that is to say, you assemble the fixed form cylinder and the lid. All right, now what you have to do, you need to place the specimen in the center of your fixed form. All right, and then now once let me show you, these are my sulfides, grains. Okay, and then make sure they are placed upside down. All right, so let me show you something. Let's say okay, let me find the sulfide quickly. Okay, this is my sulfide. All right, so you're gonna place it upside down. Okay, you're gonna place it upside down like that. Okay, like that, like this. Now how do you get these sulfides? Remember, you need to separate the sulfides from the silicates, but you know, it's a challenge to completely separate the sulfides from the silicates, which is why I'm just sticking I'm using the sulfides with a bit of the silicates. But now you place them upside down like this. Right, now after placing them upside down like this, okay, and then remember I said you place this specimen in the center of fixed form. All right, and pour the resin into the mounting cup. Now you've placed it like this. Okay, you place it like this. Now make sure you don't have any leakage. All right, okay, make sure everything is fine like this. Now this is now what we call a mounting cup. All right, now what are we going to do now? You're going to make sure that you pour this mixture to about, let's say 3 millimeters. All right, to about 3 millimeters. All right, now let's do that. All right, that's nice. Now you remember, what did I say we use this paper for? To remove the mixture. All right, now after doing this, you are going to put the, because if you don't have what we call the vacuum, you can use the cup, this cup, and then place it like this for about a day or 2 days. All right, so we're gonna leave this here for a day in a cool area, and then tomorrow around this time I'm gonna come and see what would have happened. So stay tuned, and then let's see what will happen next. Now, after you poured your mixture into the mounting cup, this mounting cup, you need these stickers. Okay, you need these stickers for naming your samples. All right, and then you can name your samples and then write whatever number, 1 or 2 or 3 or 165 or whatever. And then why should we name our samples? I mean, so that you are able to track your samples. All right, just imagine you are having around 25 samples, and then you don't know which sample belongs to whatever borehole. All right, how are you going to interpret your results if you don't know which sample represent a particular geological unit? So which is why we need to have these stickers to name our samples. All right, so you write on the white part, not on this on the back of this white color, and then after that, as you can see, you put it just like that. All right, remember, don't forget that this is upside down. All right, and then if you like, you can push it a bit. If you a person with accuracy, you can put this at the center so that everything is perfect. Now after that, don't forget that you kept this. All right, why are you doing this? To make sure that no moisture enters or no air or oxygen enters within the cup. All right, so we need to make sure that we avoid oxygen, because if there's oxygen, you're gonna see those bubbles again, and remember, we're trying to avoid them. If you don't use these cups, you can use what we call a vacuum. So you can use what we call a vacuum. So remember, we said we're gonna leave the samples like this in a cool area for about 24 hours, so just 12 hours. All right, and then we'll see after that time, or will they be enough. Then now after the time, after the 12 hours or 24 hours, what are you going to do? You just remember this, it's your mounting cup. You just push it. Okay, you just push your cup like this. Okay, you separate the fixiform, all right, from the lead. All right, and then what are you going to do? You will find the sample right inside this, and then what are you going to do? You push this, you push this until you are having something of this nature. Okay, now this is your final product. You can now see that we have got less of the air bubbles right on top. All right, then, but it's a bit sticky, so I'm gonna leave this for another day. Now can you now see my sulfides are right on top? And then what are we going to be doing? It's still sticky, so you can't polish it as it's like this. Okay, and then I'm gonna leave it for another day, and then until it's ready to be polished. So good people, this is what we call the cold mounting, for mounting what you call some zircons or some sulfides. All right, especially when you want to do what we call the in-situ analysis, right? And then now you can polish it, and then remember, as you're polishing these, make sure that you are having a microscope to make sure that the surface is always flat. all right? And then always make sure that you don't remove your sulfides. And then now after that, you can take your sample for further analysis, such as SEM, and then SIMS, so laser ablation, and many others, all right? So yeah, that's how we are making what we call the cold mounting, all right? Okay, so as I've said that it's a bit sticky, so you can leave it for another day until it's completely dry. We are back yet again. I hope you guys enjoyed watching a step-by-step process on how to make the cold mountain, all right? Isn't it funny? Making this beautiful thing, and then which is ready for analysis. This is now a resin, all right? Now basically now you can see that the cold mounting, it's good for analysis such as in situ analysis, all right, which is these days it's widely being applied, the in situ analysis, and then usually it is analyzed using what we call SIMS, a secondary mass spectrometry, or laser ablation, all right? Now what are the benefits of using these cold mounting than hot mounting? Now you can see that the cold mounting, it provides the protection and support of the sample surface, all right? And this cold mounting makes it easier to handle the sample, and also allows for several grains to be mounted on one sample or in one mount. So these are some of the benefits or advantages of using the cold mounting. So which is why scientists these days are using these cold mountings, especially for in situ analysis, all right? Ladies and gents, thanks for joining us today in this adventure. Your support, it's really appreciated. Please keep on subscribing, liking, and commenting on our channel to help us grow this channel, so that we keep on producing the content like this in this channel of ours. Please help us grow this channel so that we can become the next big thing of the future. Until next time, cheers.